In this video, I'm going to study about applications of the first derivative to understand increasing and decreasing intervals for the function. Here, this topic also related with the slope of tangent line and geometric meaning of the derivative. We know that derivative is normally is equal to slope of tangent line. Actually, we know that's one also, slope of tangent line. And we know that tangent lines m is equal to tangent of alpha also. So when alpha is greater than 90 degree, or between 180 and 90 degree, the slope m is less than 0, it must be. And when it is between 0 and 90 degree, as it is written here, m must be positive slope, it must be. So the function, if it is increasing, when you draw your tangent line, the slope it's going to be positive. And when the function is decreasing, when you draw your tangent line, here the angle, as you see, it's going to be greater than 100 and which is greater than, m is here greater than, actually the alpha is greater than 90 degree, as you see. And when the alpha is greater than 90 degree, it means that this is negative, m is negative, or derivative is negative here. So if f is increasing, f derivative x is greater than 0. If f is decreasing, f derivative x is smaller than 0. It's going to be. This is the summary of this subject. And we have one application to see. As you see, if you concentrate to this one, when I'm decreasing the value, a value, as you see, now it's decreasing. Decreasing means it's going down, and here it's going down with respect to y values. Of course, we are talking. It's going down, down, down. It's going down, and here it is. The derivative is, when it is down, it's going down, the value, derivative is 0. Then after this point, as you see here, the derivative at this point is going to be equal to 0. This is the maximum point and minimum point. Later we are going to understand that one. Then as you see, the tangent line, this is the tangent line, and when it goes up, the derivative, it becomes bigger than 0. As you see, the tangent line, it's going up, and it's when it turns down again, the derivative becomes less than 0. So to understand this function is increasing or decreasing, we should get the derivative of the expression. Fx is equal to 5x plus 4. The f derivative x for the first one, it's going to be equal to 5x plus 4 derivative, which is equal to 5. And this number is greater than 0, so fx is increasing function. It's going to be increasing function is going to be. And the second one, f derivative x is equal to minus 3. It's going to be directly 3x plus 4 derivative is equal to minus 3. And minus 3 is less than 0, so fx is decreasing function. It's going to be function is going to be. Now we are going to try to understand the increasing and decreasing on an interval. In the previous page, it was greater than 0, then always greater than 0, so it was always increasing. But as you see, the graph also I gave consciously to see sometimes it's decreasing and increasing, and try to understand that one. So the rule is same. F derivative x is greater than 0 in the function is increasing on the interval. This is the difference here. F derivative x is less than 0, so f is decreasing on the interval I, it's going to be again. So we are going to try to understand when the function is greater than, when the function is decreasing, when it's increasing. Actually, when you look at the graph, as you see, the function is decreasing till 2. So we are going to say minus infinity minus 2. This is decreasing. Then decreasing, it's going to be, and from 2 to infinity, it's going to increase, and these are going to be open. So decreasing and increasing, it must be. From the graph easily we are understanding. But if we don't have the graph, how we are going to understand these are increasing or decreasing? Okay, the derivative, first derivative, it's going to help us. First, let's find the derivative of the expression. F derivative of x is equal to 2x. Derivative of x squared is equal to 2x. Derivative of minus 4x is going to be equal to minus 4. Derivative of 3 is equal to 0. Then, when f derivative x is equal to 0, we are finding the critical point. 2x is equal to 0. We are going to find the critical point. 2x minus 4, when it's equal to 0, x is equal to 4 over 2, which is equal to 2. And I said this point is the critical point. Critical point it's going to be. And then, when you find the critical point, we are going to draw the line again, and we are going to try to analyze the f derivative x. F derivative x here for the 2x minus 4, the critical point is 2. Here this side is minus infinity side, this side is plus infinity side. And on this side, the function is going to be positive. If you remember, the sign is positive, and then this is positive, then it's going to be negative. If there is another root, then plus it's going to be. We studied for the inequalities. This is f derivative x, but we are going to try to understand when the function is increasing or decreasing. So, when f derivative is negative, function is decreasing. When the f derivative x is positive, function is increasing. So fx is decreasing here between minus infinity and 2. The function is decreasing. 2 is decreasing, and between 2 and infinity, this is going to be plus infinity, this is minus infinity. 2 and infinity, function is increasing. Here the function is decreasing in this interval, and this arrow also shows that the function is decreasing, function is increasing. Why function is decreasing? Because the f derivative is negative. F derivative negative means function is decreasing. F derivative positive means function is increasing. If I solve this question, another question again, f derivative x is going to be equal to firstly 2x minus 10. Then f derivative x is equal to 0. This gives us the critical point. 2x minus 10 is equal to 0. 2x is equal to 10. X is equal to 5 is going to be. So I'm going to find the critical point. Here this is the minus infinity side, this is the plus infinity side, and the critical value is 5. And for the f derivative x, when the values are greater than 5, as you see here, this is positive, here positive, so plus it's going to be, and here it's going to be equal to minus sign. But this is for f derivative x. We are looking for fx, and for understanding the fx here, we are going to check the function is decreasing or increasing. If the function is f derivative x is negative, function is decreasing. If the derivative of fx is positive, function is going to be increasing. So in minus infinity 5, function is decreasing. 5 to infinity, function is increasing, is going to be. Okay. On the new question, e to the power of x cubed minus 3x, and to understand increasing or decreasing, we are going to get the derivative. F derivative x is going to be equal to e to the power of fx derivative, which is equal to e to the power of fx times f derivative x. F derivative x is going to be, which is equal to, for this question, e to the power of x cubed minus 3x times x cubed minus 3x derivative, which is equal to e to the power of x cubed minus 3x times 3x squared minus 3. It must be, as you see here, when this expression is equal to 0, to find the critical point, e to the power of e to the power of x cubed minus 3x always greater than 0, it's going to be firstly. The second one, when this is equal to 0, this cannot be equal to 0. We know that one. When e to the power of x cubed minus 3x times 3x squared minus 3 is equal to 0, for finding the critical point, we are doing this one for the critical points for this question, and here points we are going to find. This cannot be equal to 0. We know that one. We know this one very well. This cannot be equal to 0. So this must be equal to 0. 3x squared minus 3 is equal to 0. X squared minus 1 is equal to 0, or 3x squared is equal to, we can write like this also, 3x squared is equal to 3, x squared is equal to 1, and x is equal to plus and minus 1. So for the critical points, we are going to get the intervals like this here. Here, as you see, minus 1 and 1, it's going to be this side is plus infinity, this side is minus infinity side. Here, and the f derivative x, which is, this is the f derivative x actually, and f derivative x is going to be equal to, here, the positive and negative signs I'm going to put here, plus, minus, and plus. It's going to be why it's like that. If you ask, here the signs are positive, as you see, and plus here, plus times plus, the sign it should be plus. Then it's going to be minus, and then it's going to be plus. We know this one from the previous subjects. F derivative x, if it is plus, minus, plus, then fx it's going to be increasing, decreasing, and increasing again. Here we have the graph for that one. I draw with GeoGebra program, and when we analyze the GeoGebra program, as you see, follow this dot please. Here this is the line now, and when you get closer, this is the e to the power of x cubed minus 3x graph, and I'm getting closer to point minus 1. And when you see at the top here, it is the minus 1. X is equal to minus 1 value, and till minus 1 the function is increasing. If you remember our graph here, and till minus 1 function is increasing. As you see here also, the function is going to be increasing. Then after this point function it starts to decrease until 1. After 1, the function is going to start to increase again. As you see here, function is increasing after this point, and we proved by the graph also. Okay, now here in this question it says that for all values it should increase. So when we get the derivative expression here, f derivative x, it's going to be 3mx squared minus 4x plus 2, which is quadratic form. And when quadratic form always positive and always negative, we should try to remember that one. For the function ax squared plus bx plus c, when we say here, when we draw the graph here, it should be always positive, means this case it was, which means a is greater than 0 and delta must be smaller than 0. If delta is greater than 0, if you remember, the function is sometimes delta is less than 0, delta is greater than 0, and a is greater than 0 case, it was like this, which means here it was like this, which means plus, minus here, and plus here, which is also similar case with this expression, plus, minus, and plus. But here we cannot find root, and that's why the function is always positive. So there are two conditions here. A must be greater than 0, which is 3m here. 3m is greater than 0. This is the first condition. And the second one is delta is less than 0. It must be, which is 3m is greater than 0, and b squared minus 4ac less than 0. It must be, and that's equal to minus 4 squared minus 4 times a is equal to 3m times c is equal to 2 less than 0, it must be. And here that's going to be equal to 16 minus 4 times 3, 12, times 2 is equal to 24, less than 0. And we may send the m to the other side. 16 is less than 24 over 24m. Then if we send the 24 to this side, 16 over 24, it should be greater than m. And when you simplify, 2 over 3 is less than m. And here m is greater than 0, m is greater than 2 over 3. The intersection of this one, it's going to be like this, and m is greater than 2 over 3 is going to be the